Good afternoon, everyone, and welcome to my talk. It's always fantastic to come back to Oslo. I really love coming here, been here a few times now. It's one of my favorite places. My wallet disagrees with me, but I love it. So my name's Adam, and I work for a company called Particular Software. We are the makers of a product called Service Bus. Has anyone here heard of Service Bus? Wow, that's most of you. That's really great to see. So I'm not going to be talking about that today, but I will say that at Particular Software, our mission as a company is to help developers and organizations to build complex software systems. And in doing that, we talk to a lot of people. So we come to conferences like this and speak to senior developers like yourselves. We hold workshops. We do a lot of customer support as part of our Service Bus offering. And we talk to people about complicated, gnarly technical problems that they're having with their systems. And it's very often we find that we look at these problems and we think to ourselves, if the service boundaries were a bit different, some of these problems may just fall away. We may just not be having to have this conversation at all. And this happens so often, it's such a common theme, that I think it's really important to talk about finding your service boundaries and how we can find the best service boundaries for our systems. Now, I may well, during this talk, take some of the ideas that you may be familiar with, some of the common practices and the things we've been trained to do as developers, and I may just kind of blow them out of the water and turn them upside down. Now, if that's the case, do challenge me on these things. I do like to be challenged on these different ideas. I don't know how much chance we'll get to do a Q&A during this session. To be honest, I'm finding it difficult to even see some of you. But I am going to be around for the rest of the conference. So if you want to challenge me on some of these ideas and ask me some more questions about this weird stuff that I'm going to be talking about, please do approach me. Please just grab me anytime. My Twitter handle is on the top right as well, so you can tweet me anytime. I can open up a direct message channel and we can have a chat. We can even arrange to meet somewhere. So let's dive in and look at a system. So this is a system. It doesn't really matter what system it is or what these things are. If you're a C# programmer, these might be classes. But we tend to structure our system into smaller pieces. So we don't just write a program.main and kind of shove everything in there. Or at least I hope we don't. I used to write programs like that when I was learning in the 80s. But these days we tend to structure things into smaller things like classes or functions if you're an F# programmer. Doesn't really matter. Now, this looks quite nice. So we can see exactly kind of what's calling what here. And we can see that there's kind of a sub-module up here that's doing something. There's another thing down here which is doing something. But at this point, we haven't actually drawn any strict boundaries. So this is just a bunch of classes acting together to do some work. Now, what tends to happen is the business will come along and ask for a new requirement. And you take a look and you think, OK, I think we can do this. But what we really need to do is we need to make a decision in the class up here. We need to make some kind of change here. And we need some data that's located down here. So how are we going to do this? Now, we could think about restructuring things. So we could think about moving some responsibilities around and changing things around. Or we could just make a call from that class to that class. Now, this is kind of what classes are designed for, right? Classes are designed to have nice encapsulations with a nice interface, communicating their purpose. So we think, OK, well, that's kind of going to be OK. We're not really messing the diagram up much, and it doesn't really matter that we're making this call. So let's just try it and see if it sticks. So you make the call, you roll it out into production, and the business have got their new feature, they're happy, and you're happy, and everything seems to work. Sooner or later, they might come along with another requirement, and they might say, well, you know, we need to do something up here, but we really need some kind of piece of data that's in a class down here. And you think, that thing that we did 3 weeks ago, that kind of worked. It didn't cause any bugs, it didn't really cause any problems. So in retrospect, it was probably the right thing to do. So think, well, should we just kind of do the same thing again? Why don't we just make a call from that class to that class, and we should be OK. You roll that out into production, everyone's happy, you're happy, the business is happy. Sooner or later, you find yourself having to do the same thing, and you can kind of see where this might start to go. Over time, and it might be a long period of time, you may be working towards something like this, where kind of classes are calling classes all over the shop. Now, the problem is, at this point, it becomes difficult to think about different parts of the system in isolation. So you kind of have to, if you want to make changes now, you have to kind of go on a kind of code safari. So you can have to sort of delve into the code, try and make some changes, trying to work out what class is calling what class, and you kind of hope you don't introduce any bugs, and you're operating in this kind of edit and pray mode of operation, kind of making edits and praying that they're going to work. And it becomes, and you get things working. You roll a new feature into production, and then your colleague might say to you something like, well, did you use a system diagram to help you? And you say, what, this thing? That thing is absolutely useless. I can't make head or tail of this thing. So you start to get the idea that the different lines in the diagram don't really mean much anymore. You can't really follow them. You can't really derive any meaning from them. So you may as well just take them out and just draw a bunch of boxes. Now, at this point, all we've got really is just a bunch of classes. And you can look at each class in isolation and say, OK, this class is doing this thing. It has this nice name. It's got these properties and these methods. But when it comes to making a change, you're still operating in this kind of code safari method of work. You kind of have to look at clumps of things at the same time and try and work out what a change will affect in what class and what classes are calling which classes. And it becomes difficult to actually look at these things in isolation. You can't say, oh, for this new feature, let's go and change that class. You still have to kind of try things out and see. So there's not really much point drawing the individual boxes anymore. You may as well just draw one big box. And at this point, you kind of realize that what you've actually got now is what we sometimes call a big ball of mud. Now, has anyone seen this kind of system at some time during their career? That's probably at least half of you. I have a lot. So I would say I've probably spent most of my career working with systems that unfortunately have fallen into this architectural pattern. Now, we know we can do better. So we read about service-oriented architecture, and we split our system into 4 services, let's say. And what we want to do here is we don't want each service to be chatting constantly to another service. We don't want to be doing a whole lot of request response between services and sharing data around, because that would lead us down to a road of tight coupling. We want to have small, thin, I've deliberately drawn these very thin and not very many of them. We want to have lightweight communication between the services so that we don't end up getting it back into a kind of big ball of mud scenario. Now, that's all well and good, but sooner or later the business is going to ask for a feature, and you think about it and you say, well, okay, we can do this, but what we really need to do is to share one tiny bit of data between the top 2 services. And it might be something really innocuous, like the price of a product, right? So it's just a number, 99 krona, whatever it is. How much harm can that cause? It's not really making things tightly coupled. We're not really increasing the amount of knowledge between those services very much. So you make that change, roll that out into production, and everyone's happy. Sooner or later, you get another requirement, and you discover you need to share a bit of data between the 2 left services. And again, it might be something really innocuous. It might be something like inventory, stock level of a product. So how many widgets have we got? 100. It's an integer. What possible harm can an integer cause? So you make that call and you roll that out into production. Now, you can see where this might lead us over time. And this could be a large amount of time. It's not necessarily this is going to happen straight away. But over a large amount of time, we may start to move back towards this kind of spaghetti type model. We've got services calling services, and they're getting very chatty. And before we know it, we're back into the big ball of mud scenario. Only this time, it's a big ball of mud with a difference, because we've split this into 4 services. We may have been rolling these out into 4 different machines. You've now got a more complicated deployment model. You can't just roll out one thing. You might have to roll out 1, 2, 3, or even all 4 of them at the same time. They're talking to each other over the network. Even if it's local host, it's still a lot less efficient than making in-memory class-to-class calls. So we can actually end up in a worse situation than when we started with. And that's a shame, because service-oriented architecture is supposed to fix things for us. So how can we avoid coalescing back to this kind of big ball of mud scenario? Well, let's have a look at a workflow. I'm sure most of you have bought something on Amazon at some stage or something similar. When you buy something on Amazon, you start a workflow. So you say, place your order, first of all, and then you might select your shipping address, where you're going to actually get this, where you're actually going to receive this book, or whatever it is you're ordering. You put in your credit card details, and et cetera, until you actually place your order. Now, Amazon is not a monolith. It's actually probably, it's actually probably one of the most service-oriented companies in the world. There is not an 1 terabyte Amazon.exe that they roll out. It's a bunch of different services. So you can imagine there's a lot of services going into this workflow which are orchestrating together to make this happen. Now, if we look at the events, or look at the back-end messaging and events that happen when you place your order, it might look something like this. So we have here a sales service, a finance service, and a shipping service. When we click that button, we can send a command to the sales service to say, place your order. Sales can then go and do whatever logic it needs to do. Have we still got this item in stock? Is it still for sale? If it's not in stock, can we order more, et cetera, et cetera? And in the end, it says, OK, we're good to go. The order's been placed. It can publish an event which finance and shipping can subscribe to. Finance, when it receives that event, it can bill the customer for that order. It can raise an order build event. And then when shipping knows that the order's been placed, the order's been billed, we're good to go. Ship it out the door, raise another event, an order ship with something else then might want to carry on with in that workflow. The question then is, what should each of these events contain? Should the order placed event contain all the information that shipping needs in order to ship the item? So the address, et cetera, et cetera. Should the event contain all the information that finance needs to complete the order, to bill the customer? Credit card details and that kind of thing. Now, that would work, right? That would work. But what's the problem with that approach? It's coupling. Right? We're getting back into a highly coupled situation. If that event needs to have the address, the shipping option, the credit card details and everything on it, we can no longer make changes in an isolated fashion. If we want to change anything about how we ship things, or how we bill for things, we're going to have to make changes in sales as well as finance, or sales as well as shipping. Imagine if we wanted to start charging in Bitcoin. We'd have to give sales all the information about how to charge in Bitcoin, all the data that's required, so that it could pass on that information to finance. What if we wanted to start shipping ebooks? We don't send an ebook to a physical address. That would just be weird. So we don't want to give that. We don't want to give sales all the information about how we ship an ebook, so it can pass that on to shipping. Now, what I just described are fat events, right? And you can see that if we were to start shipping ebooks and charging a Bitcoin, that event will get fatter and fatter and fatter with more information on it. Some things allowed to be null, but other things must not be null when they're null, and it gets really complicated. What we want to do is have a look at how we can get those fat events back down to thin events with not much information on them, a much more loosely coupled system. What if we could get those events down to just an ID? So what if sales said, order 123 has been placed? Finance says, right, order 123, I know how to charge for that order. I'm going to charge a credit card, or I'm going to start a Bitcoin transaction. We then say order 123 has been placed to shipping, order 123 has been billed to shipping, and at that point, shipping can say, right, order 123, I'm going to ship that to a physical address, or I'm going to send an email. Now, that would work fine as well, but we've got a problem here. If sales is responsible for creating orders, so sales is the only thing that can say, yes, we can fulfill this order, at that point, it will create an order object with an ID, and it will save it to its database. Now, how can finance possibly know about that order before it's been created? How can finance know what to do for order 123 if we're not creating the order ID 123 until we create the order in sales? It's a chicken and egg scenario. But the thing is, what we've said so far is we're going to create that order at the end of the workflow, right? So we're saying we're creating it when we place the order. What if we turn that upside down and we create the ID right at the beginning when we proceed to the checkout? We can do it right here, proceed to checkout. And you can do this client side as well, right? You can create a GUID client side. Now, what this allows us to do is when we go into the rest of the workflow, we can say, right, shipping, here's the address, and the order ID is 123. Because we already have the order ID when we said place order. When we go to finance, we can say, right, here are the credit card details for order 123, et cetera, et cetera, et cetera, until you get to the end of the workflow, and that's when you send that command to sales to say place order. Now, if we want to introduce something like Bitcoin payment, we can make changes just in the finance service. Because when finance service gets order 123, it can say, I know how to charge for this. It's either a credit card or it's Bitcoin, and I can do the appropriate thing. Similarly in shipping, we can now ship ebooks without having to make changes in sales. We can do that isolated just in shipping. And the one weird trick that enabled us to do that was setting the ID at the front instead of at the beginning. Now, you might be thinking, what if we tell the system where to ship our order, we tell them how to charge for it, but at the last minute, your spouse walks through the door and you say, oh no, I better not order this, they'll be mad. So you cancel the order, you close the browser. Shipping's going to be sitting there with a whole bunch of addresses, which it's never going to ship to. Finance is going to be sitting there with a whole bunch of payment details, which it's never going to charge for. Isn't that redundant data? Isn't someone going to have to come along and clean this data up? We don't want to be holding all that junk, right? But is it really redundant? So some businesses would kill for that kind of information. They want to know who's selecting products and where they're wanting to ship them to, but then don't complete their order, right? Because then you can give that to kind of your design team and your workflow team, and you can say, well, how can we make this better so that more people actually go and finalize the order? So it can actually be really, really useful information. You can get rich business data analytics from that incomplete order information. Storage, it's going to be a row in a database. Who really cares about how much that's going to cost? But ultimately, you don't really have to keep it in a database either. So some services might choose to hold it in some kind of session state. That might be more applicable for finance. You don't necessarily want to keep credit card details sitting in a database. You might choose to hold them in session state. So that will go away if the order's cancelled naturally. Now, so what is it? Why is it that we end up in this big ball of mud scenario if we can do things like we just described, where we're only sharing IDs? Well, it was this here, right? That's where the problem started. It was the sharing of data. As soon as we started to share data between services, it got this kind of ball rolling down, and it got us kind of moving towards that possible end of that big ball of mud scenario. So this is what we want to avoid. We want to avoid sharing data between services. So let's try and formalize a little bit about what services actually are and aren't. First of all, what are services not? So a service which only has functionality, like a calculation or a validation or something like that, that's not a service. It is just a function. Something that gives you CRUD, kind of create, read, update, delete functionality on records, that's just a database. Right? It's not a service. And really importantly, just because you put HTTP on front of a database, it doesn't suddenly make it a service. Right? It's not some kind of magic dust that you sprinkle on a database and go, hey, presto, we've got a service now. It's still just a database. You've just changed the kind of technical access point into it. A service is the technical authority for a specific business capability. The word business is really important here. Services are aligned along business capabilities. They are aligned along business rules and not technical rules. And because all the code we write belongs to some kind of business capability, I mean, we don't just write code for fun, right? Or, I mean, sometimes if you know your project's going to fail, you can just kind of go and learn Rust or something. But if you're in a normal mode of operation, all the code you write is for some specific business capability. That's what we're paid to do. So it then follows, if services are the technical authorities for business capabilities, all code must belong in some kind of service, right? So nothing is left over after identifying services. If we look at systems versus services, these are two very different things. So sometimes we might have a mobile app, a back-end app, a Java portal, or something like that. Now, it's very tempting to say, well, why don't we just say that each of these are our services, right? We've got a front-end service, a back-end service. I'm sure we've all heard that at some time, a back-end service, right? But the thing is, services operate along a different dimension. They are business aligned, which means they can cut across all these kind of different technical layers. Now, the implication of that is that service one here may have an Objective-C component which ships into a mobile app. It may have a .NET component which ships into a .NET backend. It may have a Java component which ships into this portal. It's a many-to-many relationship. So systems can consist of components from many services. A service can consist of components shipped into many systems. I sometimes think of it if you think about when you're playing with Lego, and you know how you start off with that kind of green board, and if you're really obsessive like I was when I played with Lego, I'd have my bricks sorted into different piles, so like the big pieces, the middle pieces, and the small pieces, and then I kind of pick bricks from each pile and kind of build a house or something on the board, and that's my system. Right? That's very much how that very much is very much the relationship between systems and services. Services are logical design time concerns with business-aligned boundaries. Systems are physical runtime concerns aligned along technical boundaries. It's very important to make that disassociation. So if we try and dig into a typical domain and look at how we tease out these different boundaries, we might first of all see something like this, right? So we speak to our our business stakeholders, and they say, we've got products, and we sell those products to customers. So one of the kind of intuitive things we do is we get around a whiteboard and we write customer, product in 2 boxes, and we start from there. And then the business tell us things like customer has a first name, customer has a last name, customer has a status. And it seems natural then to kind of code some entities which represent those things, so we can really write our code in the business language. But the thing is, what we want to be doing is we want to be looking inside those entities. So we want to be looking at what is the relationship between first name, last name, and status, for instance? Why are they in the same place? Now, there's a really good technique for this called anti-requirements. The interesting thing about business stakeholders is they often don't know what they want, but they will almost always know what they don't want. So you can ask really dumb-sounding questions like, okay, if the customer's last name is 20 characters or more, does that affect their status? And the business will turn around, look at you and say, you have no idea about this domain at all, have you? That is so stupid. Not only would we never do that, but no company in our entire industry would do something so ridiculous. Now, if you hear that, you've basically struck gold. Because what that means is the business have just told you a stable business rule. They've said that there's no relationship with a customer's name and their status. That gives you a strong sign that you should actually take those 2 things and put them in 2 different places. At this stage of modeling, we're looking to put these things into different piles. So we're taking all the data, we're kind of breaking it up into its bits, and we're trying to put it in different piles of things. And this can eventually lead us to discovering where our service boundaries are. What we can do now is we can say, well, customer status, it's sitting there all on its own, looking lonely. So what is customer status? What do we use customer status for? And they'll say, oh, well, we use that to work out the price. So when someone's actually going to pay for something, if they're a loyal customer or if they're kind of somewhere in the bronze, silver, gold hierarchy, we'll give them a discount or something like that. So okay, so customer status has got something to do with price. I'm not exactly sure how they relate yet, but let's put them in the same pile. Right? We've got a strong intuition they belong somehow together. Then we can look at what we've got left. We've got name and description of the product. Well, the description should somehow kind of complement the name. If it's a luxury something, you want the description to say why it's a luxury something. So we're going to put those in the same pile over here. Now, you can see now that we've ended up with a very different model to what we had at the beginning. And that's because we're looking at the behaviors and the use cases and the scenarios. We're not thinking in entity terms. This is what modeling is about. Modeling is not about tangible things, but our brains are kind of hardwired for those tangible things. We like to look for things that we can kind of recognize and hold on to, like a customer and a product. We like to start off at the high level. We don't want the business to tell us all the details to start off with. Let's just start at a high level. Okay, customers and products, let's draw those two boxes first, and then let's dig into the details later. We need to turn that practice upside down. It's not the high-level entities that lead us down the right path. We need to be looking at the field, not the entity. Looking at the use cases and the behaviors, the actual data that takes part in those behaviors. That will lead us to a very different model. At the beginning, I said, customer has a first name, customer has a last name, customer has a status. If you hear yourself saying that, and look for that phrase in the middle, look for that has a. If you hear yourself saying has a, it's a strong indication you're thinking about an entity-first approach rather than use cases. Another thing to really watch out for at this stage, another common pitfall, is naming things too early. Resist the temptation to try and name these three things too early. I often say that you should just give them kind of meaningless names like red, green, and yellow to start with, or it can be names of planets or names of something else, but try not to give them business meaningful names. The problem with giving things names early is that those names get in the way. So you'll end up having conversations around the whiteboard, and someone will say something like, okay, hang on, stop. That can't possibly belong in there because that's billing. Or they'll say, oh, I know exactly where this thing belongs, it's in inventory. The problem is that you'll be tempted to put things in the wrong places or not put things into places just because of the names you've chosen to assign to them. So do the naming much later. Once you've gone down, once you've done more of this modeling, or you've even got things into production, then take a look at the different piles and then think about what you would name that. Try not to do it early. Sometimes it's even better just to never give them meaningful names at all. I've done that in one of the teams that I was previously in. We used kaiju monsters. So the most famous one is Godzilla, and then there's other ones like Mothra and Batra and all these things. We just said we're going to leave those names in place forever. We're not going to try and give them meaningful names, because meaningful names we actually discovered on another project really got in the way. Now, that's also easier if you're working in a bit more of an abstract domain. So that was actually in a bank, and it was all to do with trading on financial markets. Now, as an individual, I don't really do a lot of trading on financial markets, and a lot of this was more abstract. So it's more obvious that, or it's less tempting to try and assign names early. With something like customers and products or something more familiar, it's often more tempting. But we need to try and resist that temptation. So how can we use these techniques on a bit more of a realistic domain? So let's look at hotel. Again, we've all kind of stayed in hotels at some point. Now, again, here it's tempting, when you start looking at hotel domain, to start drawing boxes on a whiteboard, things like rooms, guests, bookings. You know, it's very intuitive to start at that kind of entity-first model. But we need to resist that, right? We need to start looking at the use cases. So the first use case we're going to look at is search. So when you search for a room, it will tell you things like the room type, details about the room, and a price, and this will be for certain dates, right? So from a from and to date, these are the room types that are available. And importantly, it is a room type. Okay, so you don't book room 423, you book a superior room or an economy room. If we look at the data that we've got on this screen, let's have a think about what is it that we need to say that a particular room type is available on a certain set of dates. Well, first of all, we have this notion of room type. And at the moment, all we really need is an ID, right? So we've got a room type ID. We don't need to model further than that right now. And we then need to know a kind of from and to date, right? So we need to know the actual dates that the person's looking for. And we need to know for a particular room type, how much capacity we've got of that room type. And what makes a room type available or not it's the current amount of bookings, right? So we need some kind of booking ID in here as well. Now, this is not a table, it's not a database table, but you can kind of see that using a combination of this data, so from and to dates, room type ID, how much we've got of that room type, how many bookings we've got for that room type. From here, we can work out how much of a room type is available on a certain set of dates. The next thing is the price. Now, the price of a room isn't really affected by whether it's available or not. I know you might be thinking of airlines, where as it gets closer to the date and less seats are available, they put the prices up. But hotels don't actually tend to work like that. They tend to just sell big blocks of rooms to booking.com, for instance. And once the price is fixed, the price is fixed. So we're going to put price in another pile, right? We're going to put it over here with room type ID into another pile. And one thing that can affect the price is the specific date, right? So we might charge more at weekends, we might charge less at weekends. It depends where the hotel is. Is it in a holiday resort or not, or is it in the city? So we need some kind of notion of date in this pile as well, because price varies with date. And then we've got other things like the name and the description and the photo. So we want these things to kind of complement each other. If it's a luxury room, we want the photo to look luxurious, and we want the description to explain why it's a luxury room and why it's more expensive. Now, the next part of this workflow is actually selecting this room. Now, what's really important is that the price that is shown here, and I know that's very small, but that says 3,937 NOK for the entire stay. We want to show that same price in the next screen when we select that room. Now, this is now showing an average price per night. I think this is probably the most expensive night in that stay. But the important thing is that this 3,900 NOK here is the same 3,900 NOK here. And that's really important because you don't want someone to click through and say, and the price will suddenly go up, right? That'll be very bad at user experience. In fact, there are laws around that, right? If that happened, that would actually be counted as false advertising, right? So you can't advertise at one price, click through and see another price. So what that means is that we now somehow need to associate a price with this workflow that this user is actually having with our site right now. Now, remember what I said about creating the ID up front. If we create an ID up front here, before when we get to this screen, so when they actually search, we can create a booking ID, right? Now, it might sound a bit strange because the booking's not really finalized until you've paid for it. But we've already talked about having that, what some people would consider redundant data early on in the process. So we can create the booking ID right here, and we can associate that booking ID with the price on this screen. So when we go here, we've got the same booking ID, and we can receive the same price on this next screen. So the question now is, how do we associate the booking ID with the price? We've got two options. We can move the price from green to white. We can copy it. We can duplicate the price from green to white. Or we can move the booking ID from white to green. Now, price, again, might seem like a simple thing. It might be, you might think, oh, that's just a number. It's just a price per night or price for the whole booking. But price can be a lot more complicated. If we look back here, I think it was on this one, look at all these different pricing options, standard rates, prepay and save, deals and packages. Price is actually a lot more complicated than one number. So price then is inherently a more unstable business concept because as your business users think of great, wonderful new ways to kind of make people buy hotel rooms, they might come up with different pricing structures. So we don't want to copy the less stable business abstraction from green to white. Let's copy the much more stable business abstraction of the ID from white to green. And if you think about it, an ID isn't really data, right? An ID is just kind of like a pointer to something with business meaning. Business users don't really care what's inside the GUID, or if they do, then something's really gone wrong. But an ID is essentially just kind of a pointer into something which has business meaning, but it doesn't really have any business meaning itself. Then the next stage of the workflow is to actually book your room, and this is where you put your details in, your first name, your last name, your email address, etc. And at this point, you could potentially use anti-requirements to find out where this goes. You could say, well, is any of this stuff affected by the guest info? If the guest name begins with S, does that affect the room description or the capacity or the price? And the business will say, stop asking me these stupid questions. It is completely unrelated. So then you know you can put it in another pile, right? So you put guest info down here with the booking ID again. Now, at this point, you might think, well, when you actually come around to kind of implementing this, you might discover that this yellow service down here at the bottom, all it really is CRUD on guest info. You're just creating, reading, updating, and deleting guest info. So you might say, well, is this really a service? Does it really belong on its own in another service boundary? And if there are really no business rules in there, you might choose to fold this back up to one of the other services. Now, again, take a look at this model and then think about how this might look if we'd drawn bookings and guests and rooms on a whiteboard. Right? This has led us down to a very different model than the entity model would have. And the thing is that because we've all stayed in hotels, it's really tempting to not even talk to a domain expert. Right? We've all stayed in hotels, we know how they work, we know you can book them, we know you can stay in rooms, so you just start modeling this stuff yourself. But the thing is, you're doing that from the point of view of a customer of a hotel. You're not doing it from the point of view of running a hotel. So even in those more obvious domains, it's almost always a really good idea to have a domain expert in the room. So again, use cases, details, scenarios. That's what's led us down here, not entities. Entities would have ended up with a very different model. Has anyone here read Eric Evans' blue domain-driven design book? Quite a few of you, right? So he talks about entities there quite a lot, right? The thing is that Eric actually said since then, he said he wished he put the entities part in the second half of the book because everyone read the first half with the entities and aggregate roots, got all excited and started coding, and then kind of didn't read the second half of the book. So he wished he'd changed that order. Later on, he actually said he wished he'd put it in the appendix. Later on, he actually said he wished he'd left it out altogether. So the thing is, we've got very transfixed on this whole entity approach, and we kind of jump on that as our modeling approach. But entities lead us down the wrong path. I'll even go ahead and say it. Entities are bad. Use cases, data, fields, scenarios, behaviors, good. They lead us down the right path. If you want to use entities within a service boundary as a kind of implementation detail, fine. But at a service boundary modeling level, not a very good tool to use. Another interesting domain is insurance. So does anyone here work in insurance? Must be at least some, just a couple of lucky people. So insurance companies are often modeled around the service boundaries of a front office and a back office. So the front office in an insurance company is really kind of all about fear. Their job is to kind of make people afraid enough that they buy more insurance. Have I got that more or less right? In fact, I was in Russia not long ago speaking to some people about this, and they told me that the word for insurance in Russian actually has the word fear in it. So it is kind of true. The back office is very different. They're the guys that deal with claims. So when something bad happens, you make a claim, they get a claim form in, and their job is to actually work out how little they can pay you in the face of that claim. Right? It sounds a bit cutthroat, but that's how a successful insurance company works. It's maximum money in, minimum money out, and then we make money. So what you might see is something like this. You might see you might see service boundaries drawn around those front and back offices. So we've got a policy service here, and we've got a claims service. Now, I really don't know much about the insurance industry. I don't know anything about running an insurance company, but I can look at these straight away and I can say, these are the wrong boundaries. The reason for that is, let's look at a typical use case. Imagine you make a claim on your house insurance. The first thing that the claims service is going to do is a whole bunch of request response to the policy service to find out the details of the policy. They're going to read through all that fine print and work out how they can get away with not paying you, or how they can minimize the amount of money they have to pay you. And it works the other way. So, for instance, if you make a lot of claims on your car insurance, The next time you buy a policy, that policy price is going to go up. So when they're selling car insurance from the front office, they might do a whole load of request response to the back office to find out what claims you've made. All that chattiness going between the two services is indicative of tight coupling. Right? There's a lot of data shared between the two services. They have to know about the internals of each other quite a lot. Now, it's all very easy to say, they're all wrong, but how can we find the right ones? Well, that's a lot harder. So, and this process can take a long time. So when we looked at the hotel domain, I kind of illustrated what it's like to find boundaries, but it doesn't feel like that when you're doing this in real life. So if you were called into a company as a consultant, you could easily say at the beginning, oh yeah, the service boundary's all wrong. What are the right ones? Well, I really don't know. And a lot of time can go past before you do find the right ones. It can be a slow process. Finding service boundaries is a kind of, it feels like you're kind of bumbling around in the dark, kind of trying to feel your way around. You may not make progress for quite some time, but eventually you might get some kind of insight, some kind of glimmer of hope. I think I've got something here. You might realize that home insurance actually isn't really that related to travel insurance or car insurance. So when you have a car accident, you don't show someone your sofa. They're very different use cases. And then you discover that a better way of modeling this might be home insurance, travel insurance, and car insurance. So then you go back to your business stakeholders and you say, right, guess what? I've got it. I've got it, and I've got some earth-shattering news. Home insurance is different to travel insurance. Car insurance is also different to travel insurance. And the business will say to you, how long has it taken you to work out something which I've known for my entire career? How much have we just paid you to come in and tell us something so obvious? Now, the thing is, again, when you hear that, you've struck gold, right? Because when the business says, oh, but that's obvious, you've probably got the right boundaries. Now, you might think, well, okay, well, why didn't we just shortcut that? Why didn't we just say to the business in the first place, what are your service boundaries? And they would have, or how is your business organized? And they would have said, oh, yeah, we've got home insurance, travel insurance, and car insurance. And, okay, great, those are our service boundaries, off we go. The problem is that this up here was also obvious. And the thing is that when you talk to a business person, there are many different dimensions along which you could split this. You might get lucky. They might say to you, oh yeah, we've got home insurance, car insurance, and travel insurance, and okay, off you go. Or they might say, oh yeah, we've got a front office and a back office. Or they might say, oh yeah, we've got customers and we've got products which we sell to customers. So you don't know, if you start at that high level, you don't know if you're cutting things across the right dimension. It's another example of how starting at that high level can lead you down the wrong path. It's not that the detail reveals itself from the high level. It's that the high level is revealed from the detail. You need to go down to the detail, and you might ask, well, do I really need to go to that level of detail? And the answer is yes, you do. It's only when you look at the data that takes place in the interactions of a certain use case that then you discover what data is coupled to what data. It's a bottom-up approach. And that brings us neatly onto organizations. So the front office, back office thing was an example of an organizational boundary. Now, at one time, it may have been possible to model services around organizational boundaries. If you think about the old days before things were automated with the computers, data used to exist in filing cabinets. So the cost of accessing data was expensive. A filing cabinet might be on the other side of the building. So to get some data, you actually have to walk across the other side of the building to get it. So because of that, people tended to be located next to the data. So all the data that I need will be kind of surrounding me in filing cabinets. And then to do some kind of job function, I would go to my filing cabinet, look through something, write out some kind of form, put it in my outbox, and then some kind of trolley person will come along and kind of shuffle it over to someone else, put it in their inbox. They would go to their data in their filing cabinets, get that thing, maybe write something, tick off a box, put it in their outbox, and so forth for the rest of the workflow. So because of the cost of data access, companies were almost forced to be service-oriented. right? They were forced to encapsulate their data in different departments for that reason. Now, we came along with our clever computers. We put a workstation on everyone's desk and a big database in the middle, and all of a sudden, anyone can access anything. So what we did was we took away the one constraint which was forcing companies to be service-oriented. So what tends to happen now is that managers in companies tend to kind of pick jobs from around the company. They tend to kind of swallow up job functions into their departments. Because really, anyone can access anything, as long as they've got the right permissions. So the modern department in a company has kind of become a kind of mini kingdom, where managers are kind of empire building and building up more boxes underneath them in the org chart. And the problem with that is it's not a stable business boundary. So when modeling services, we want to be looking for stable business rules. Now, I've worked in organizations before where my organizational unit, my team, has changed 6, 7, 8 times in a year. That's a very unstable business boundary. I don't want to be changing my service boundaries 6, 7, 8 times a year. So be very careful, be aware, be very wary of the organizational boundary. It's often not a very good tool for us to use. And that is a real shame, right? Because it would be nice if you could just go into a company and say, oh, you've got finance, billing, shipping, those are our service boundaries and we're done. It's a real shame. It would be nice if we could do that, but that rarely works in practice. So I do need to, of course, talk a little bit about microservices. Now, I'm sure you've all heard a lot about microservices already in this conference. I think a lot of good things have come out of microservices. We've got this concept of these nice individual, isolated, deployable units with nice, crisp responsibilities and boundaries that we can deploy in various places and use things like Docker and stuff like that. So I think there's a lot of good things there, but I do have one big concern. I'll try and illustrate it. So as we've seen, a lot of our careers are kind of, a big part of our jobs is battling against the big ball of mud. This is the thing that we want to kind of stay away from and want to avoid. So we read about microservices, and that tells us that we should try and split things up into smaller components. So we split things up into, say, 5 microservices, and this is nicer now because we can think of these things individually, we can look at them one at a time, but then we read, oh, well, 5's not really enough. You need at least 10 microservices. So you split things up a bit more, and now we've got, 13 up there. And now we think, okay, we must be doing microservices now. Now, we read a bit more literature, and it says things like, well, each microservice should really be small enough that you can rewrite it within a week. Or even worse, something like it should only be 200 lines long or something like that. So you split it up even more, and you end up with a lot more microservices. Now, that's all well and good, and that actually looks quite nice. But the thing is, eventually, the business will come to you with a requirement, and you realize that you really need to make a change up here, and it needs some data from down here. So these microservices are nicely defined. They've got nice, crisp boundaries, and we don't have any other kind of service boundaries defined here because the microservices are the boundaries themselves. So there's nothing stopping us from making that call. So we make a call from one microservice to another, and we roll it out, and everything's good. Sooner or later, we discover that we need to do the same thing again. We need some data up here from something down here. We make that call again, and we roll it out. Right? Now, you know where this is going, right? We've seen this picture before. Over time, and again, no one sets out to do this. Over time, we've got microservices calling microservices calling microservices. And this is the same picture that we saw before, right? That is deliberate. And as we've seen, we may as well take the lines out. We may as well just draw a bunch of things, like a bunch of microservices. We've seen that we may as well just take the boxes out and just draw one big thing, and we're back to our big ball of mud. But it's a big ball of mud with a difference. This time, you've got 100 microservices running on 100 Docker containers. They're all talking to each other over network, and we've ended up with a big ball of mud, microservices edition. Now, this is not what we want. We want to be avoiding this. We want business-aligned service boundaries. We want these things to have light lines of communication between them, and what is it that goes between them? It's IDs, right? Now, if we look within those service boundaries, we may have smaller autonomous components. So it may make sense for one of these services to be split up into 5 different components. One of them, it may just have one component, and others may have many more. And as we've seen, systems are not services. Systems are composed from picking components from different services into something that's deployable. So we might pick something from here, and something from here, and deploy that into an actual physical system. Now, you may be also thinking, well, isn't it possible within one of these service boundaries to build a mini ball of mud? Now, I'm not going to say that that is impossible. You know, if you're determined enough, you can build a mess using any kind of architectural approach. You know, this one down here on the bottom right is starting to get a bit complex. However, what I will say is that it's much less likely, because we've already split these things up along business boundaries to increase our understanding of the use cases and to be able to isolate changes to introduce new functionality into one place. We tend to split these things up internally within service boundaries for very different reasons. If we look at this service down here, this might have something to do with bank accounts. And it might have a few different responsibilities, like creating bank account statements or locking accounts for fraud. So let's say we think there's some fraudulent activity on an account. We want to lock that account immediately. We don't want any more transactions to happen. Now, let's say we send 1,000 messages to that service to say, create bank statements. Then we send a message to say, lock this account. Now, we don't want the locking of that account to be queued up behind 1,000 messages to create bank statements. So we split that up into 2 different components. We have one component for statements. We have another component for fraud. Each of them has their own queue. We send 1,000 messages to the bank statements thing to create bank statements. We send one message to fraud. Because they're on different queues, the message to fraud gets straight there, and that gets done straight away. The statements component, we might roll out to 2 machines just for failover. The fraud thing, we might roll out to 10 machines, 10 computing consumers. We might elastically scale it, whatever's needed to meet the SLA of locking accounts for fraud. Now, each of these things, you could call a microservice. Right? If you want to call each of those things a microservice, I have no problem with that at all. I don't really like the word microservice. I think part of the problem is in the name. First of all, the word micro, which means that size is the important factor, which I don't think it is, and service, right? So service tends to get conflated. Service is a very overloaded word, but because they're called microservices, it distracts us from thinking about the business-aligned boundaries. We get fixated with physical boundaries around deployable units instead of letting go of that and allowing ourselves to draw boundaries around business capabilities instead. So call them microservices if you want. I prefer something like autonomous components, something like that. Okay, so we're getting towards the end now. Before I wrap up, I will recommend to you that you have a look at this. If you want to look at this in more detail and you want to see some more use cases, this is actually a video package which I've put together. This is the CEO of a particular software, a guy called Udi Dahan. This is a set of videos that he produces, and they are an extract from a much larger 5-day course that he runs a few times each year. So go there, you can register for free and grab that video package and hear more about this kind of thing. So just to wrap up, one really important thing to say is that service-oriented architecture, like anything else, is not a silver bullet. It is not a golden hammer. I guess a few of you have probably read the Gang of 4 patterns book at some stage. So do you remember when you read about those new patterns and then you went back to work and you started writing everything using that new pattern? So the same thing applies here, and it applies everywhere. This is not something just to use blindly on everything and it will magically solve your problems. There is a time to use service-oriented architecture. I think the biggest example of that is startups. So is anyone here working in a startup? Or a startup-ish kind of thing? A couple of you. Startups can also be not necessarily new companies. There can be new things within a company. So an existing large company might choose to kind of spin up a new project kind of in a startup fashion. So you might find yourself in these kind of situations now and then. And the thing is, if someone comes to me and says, oh, well, I'm in a startup now, and I'm going to do service-oriented architecture, I'm going to get all my service boundaries right from the start, we're going to do it all perfectly, then I usually say, well, I've got some bad news, because you have to be very careful using this kind of architecture in a startup. And the reason for that is we want to be modeling around stable business rules. Now, startups don't know what their businesses are for at least the first few years. So if you look at Facebook, for instance, Facebook is a media company. All it does is it puts eyeballs in front of media and it sells those eyeballs to advertisers. It's quite a classic media company model. With one crucial difference is that they don't actually have to produce any content. So it's an incredibly lucrative model. But this is the thing, when you're in a startup, you've got ideas and you know that you can make money with these things somehow, but you don't really know how yet. That Twitter's another great example. So you're kind of just spreading your toys out on the floor and you're seeing what you can do with them, seeing what you can build with them. And it's not really too much of a problem if the code that you write at that phase kind of matches that and is a little bit messy and is a bit of a ball of mud. Because the thing is, if you try and look for service boundaries early on in that phase, you're going to be looking at things which are not yet stable business rules. You'll be doing a lot of guesswork around things that could change and probably will change. So in either case, even if you build it using some kind of service boundaries, or you kind of build just a thing that does something somehow, you're probably going to have to rewrite it in either case. So you're not really losing anything by just creating a bit of a mess at the beginning. So my advice on that is be very careful about trying to use service-oriented architecture and trying to look for service boundaries too early on in a kind of startup scenario. So I guess that brings us to the end. I hope that's been useful and that's given you something to think about when you go back and think about your own systems. And as I said, I'm going to be around for the rest of the conference, so do feel free to grab me and ask me for more clarification on any of these things. If you think some of these things are really just weird and wacky and won't work, do challenge me on them as well. That's when I think a lot of the most interesting conversations happen. So I'll be around, please do feel free to grab me. So enjoy the rest of the conference. I hope you've enjoyed that. I've really enjoyed speaking to you, and thank you very much.